So here we're going to solve exponential equations that have different bases, and we're going to get into something kind of complex. So this would be um, solving exponential equations part two, of complexity, or part three actually, third level of complexity. And again, I'm going to show it just two ways this time. Um, I'm going to show you the logarithmic process and then the graphical process. So we'll look at both. So we can kind of check our answers, make sure we're on track. So the first thing you do with this, and this time I'm going to use the natural logarithm. You can either use common log or the natural log, or you can use the common log. So log base 10. If you remember, natural log is really, and if I put an X there, natural log is really just log base e at x. Common log is log base 10 at x. So we're going to use this one, the natural log of x. And so that's all you do to start with. You put that natural log on both sides of the equation. So what happens is um, we can pull then this exponent out to the front in both cases because we logged both sides. When you use a logarithm on it and you have a logarithm with an exponent, the exponent is really a multiplication out front. So 2x plus 1 now is times the natural logarithm of 3. And x plus 2 is times the natural logarithm of 7. Whoops, I put the parentheses around the wrong thing. Well, there we go. Fixed it. So here you could start approximating that natural logarithm. So x plus 2 times, there we go. However, let's see if we can get the exact answer and then use the exact answer to approximate. We'll end up with a closer answer if we do that. And so the rule is get all of your x's left, all your real numbers to the right. So anything with a variable is going to move left. Anything that's just going to come out number-wise is going to move right. So first step, just like we did back in Algebra 1 in your high school days and maybe your middle school days, you distribute the number out front. So we would have 2 times natural log of 3 times x. Okay? Or maybe that x, you don't want to bury that in the natural log. You want to be careful there. So I'm going to stick it out front. Commutative property allows us to do that. So 2 times x times natural log of 3. And then natural log of 3 times 1 would be plus natural log of 3. Equals, now we'll distribute the natural log of 7. So we'd have x natural log 7 plus 2 times natural log 7. Okay. So, like I said, we're going to get our x's to the left, numbers to the right. So we need to move this x natural log 7 to the left. So we're going to subtract it over. And since it doesn't really match any of the variables, all we'd have then is 2x natural log 3 minus x natural log 7 plus natural log 3 equals 2 natural log 7. Okay. Then we'll keep going. We want to move this natural log 3 to the right, so we'll subtract it over. Natural log 3 minus natural log 3 is 0. And so our equation then becomes 2x natural log 3 minus x natural log 7 equals 2 natural log 7 minus natural log 3. Wow, that is brutal. But the only reason it's brutal is because of this whole natural log idea. You really have to think of natural log 7 as probably some number, like maybe it's off the top of my head, I won't be able to come up with it, but maybe 1 point something or 2 point something. You could go get regular numbers there and just multiply them, but I don't want to do that yet because I want to get a very accurate answer. And so your next step, and it's kind of fun to be able to do that. I'm going to come up with the exact answer. Our calculator then will approximate it. So here's the thing. Notice this has an x in common. We need to get that x by itself. So I'm going to factor it out. So you'd have x out front, and then 2 times the natural log of 3 minus natural log of 7. And if you distribute it back in, you'd end up with the same thing. Equals, and I'm just going to leave this alone right now, natural log of 7 minus natural log of 3. Okay, well, we're solving for x, so we need to get rid of this stuff by dividing it. So we're going to divide both sides by 2 natural log 3 minus natural log 7. Do the same over here. 2 natural log 3 minus natural log 7. And you're going to be really tempted to start crossing things out. The only thing we can cross out are these two, because they're exactly the same. 2 natural log 3 minus natural log 7 over 2 natural log 3 minus natural log 7. That is 1. This over here, you cannot cross out the natural log 3's. You start doing that, bad things are going to happen. Look up rational equations and simplifying rational expressions. That would be the video to watch if you're tempted to start crossing this stuff out. That's bad. That happens all the time. But please don't do it. That's the #1 mistake that I try to break people of all the time. So there we have it. We've got 2 natural log 7. So here that is the exact answer. 2 times the natural log of 7 minus the natural log of 3, all divided by 2 times the natural log of 3 minus the natural log of 7. So at this point, we need to get a calculator out and approximate that answer. So I'm going to do the top and get an approximation for that, and then do the bottom and then divide them. So in our case, and what we could do probably is plug the whole thing in and see what happens. So, oops, let me clear this out. It's freaking out on me. Let me find the C. I'm not real comfortable with this, but there's a parenthesis. So 2 times 7 natural log minus 3 natural log, and we'll see if it works. Yeah. Divided by, I hope I hit the parentheses. I don't remember if I hit the parentheses. It's going to be a lot easier because I'll forget. I don't like this type of calculator because it doesn't display what you're plugging in. And so it's a little risky. So I'm just going to find the top, find the bottom, and then divide them, which will have some problems there too. So 7 natural log, okay, minus 3 natural log equals, so on the top we should have 2.79321. Okay, then we're going to divide that by the bottom stuff. So the bottom stuff, let's clear this out, see, and so that's 2 times natural log of 3 minus natural log of 7, and we got 0.25131. 0.25131. Okay, and then you divide those two numbers. So 2.79321 divided by 0.25131 equals, and I get 11.11. I think that's bad, but we'll find out. So x so far I have is an approximately 11.11. So I'm thinking I might have made a mistake. I don't know. But here's where we'll find out. So remember, in GeoGebra, you can plug these in, or any graphics utility, and we go back to our original, and you just let y equal 3 to the 2x plus 1, and y equals 7 to the x plus 2. and we find out where they meet to see if that answer is correct. So I'm going to hit pause and pull up GeoGebra. And I better show you how to plug this in because it is a little different. So y equals 3, and I'm in the input, caret, and then I need parentheses, 2x plus 1. Hit enter, and there it is. And my other one, y equals 7 to the x plus 1. So y equals 7, caret, parenthesis, x plus 1. Enter. And just as I suspected, 3, 7, oh, it's x plus 2. See, and there I even made a mistake. So we're looking at this, and I can tell everything's all messed up. Whoops, too many parentheses. Let me get in there. 7 to the x plus 2. 7 to the x plus 2. And, alright, well, let's see if we can get these two to meet. And it's thinking about it. So, I think I got it going. Well, try that again. It didn't take. Maybe the number is too big on the y-axis. Yeah, undefined. So, we got a problem here. Hold on here. Alright, so I had to bring out the big guns. What happens with GeoGebra is I created a situation. I didn't test this before I started this problem, which is kind of cool because we're going to get to see some cool math. But 3 to the 2x plus 1, if you plug 11 into that, you end up, 11 point whatever I had, you end up with 3 to the 23rd power or so, which is in the, some number in the billions or tens of billions. You can see I typed it into Wolfram, that exact thing, 3 to the 2x plus 1 equals 7 to the x plus 2. Unfortunately, you're not going to be able to do this probably on a math exam for your instructor, but what's cool is with Wolfram, it does give you the graph, and when we plugged into GeoGebra we started to see that graph, but it was not to that scale. I don't know that I could even have pulled GeoGebra to make it that scale. And seeing where these intersect, you notice they're getting ready to intersect somewhere in the 11 region. So I think we might be okay. And there's our answer. That's our real solution. Wolfram could show you step by step. I wonder if their steps match mine. Oh, we got a GoPro to get the step-by-step solution, but that's okay. We know how to do it. And if you look down here on a number line, there it is, 11, I must be right, 11 point whatever. And again, last thing you could check, just to double check it, is put that 11 point whatever in there. So we ended up with 11.11, or 11.1. So you could go back to the original, plug in 11.1 to both of those, and see just how close you get. And so that is how you can check your answer. So that's kind of the messiness of these. I've got some other videos that show you some more practical applications of this. This is kind of the pure math realm. But kind of fun. I just love it. I love it when you get to the end and you're like, I wonder if that's right. And there you go. There's some ways to check it. So I hope this helps you. It was kind of a hodgepodge into how I problem solve, so I apologize if it's kind of junked around. It seems like the end didn't end out the way we thought it would. Well, that's math, and that's why I love that's why I'm here talking to myself at night. So best of luck. See you next time, and have a good one.